Right. So today we are going to do another network paper, and we will be doing it faster. And also, we want to finish our. We have one more topic in enterprise application that we will be doing at the end. Okay. Right. So let's quickly do the 2019 paper because we did the 2020 paper. Right. Answer question 1 to 4 using the following information. Machine in a network is configured with IP address this and net mask this. That I don't think that I want to do it, right? So 192, you know that how many ones are there, and then you convert it to the CIDR notation / notation, so that you should be able to do it. So I will use the calculator anyway. That is 2 ones. That means 2 ones are there. So that means 24 and 26. So answer must be /26. And that means D. Answer is D. What is the broadcast address of this network? So it has the broadcast address. Now we know that it is in the 26 bit, right? 26 bit is here. So therefore we just have to convert this into binary, right? I'm again using the calculator today. 132 32 132 is 140 140 100 140 100 140 100 1 2 3 4 5 6 7 8, right? And we know that it is 26. We found that so we found that it is /26 because 192. So that means two more bits. So subnet ID is when all these are 0. Don't touch this, right? And broadcast ID is, broadcast address is, don't touch this, but make everything 1. So that is how it look at the routers look at it. Okay, 1111111, and this is one of the IP address, and that will be your broadcast ID. 1248 16 32 64 minus 68 plus 3 1 11 6 plus 2 is 8 8 plus 1 is 9 191, right? 191. So this portion is not going to be changed. 192 248 16 191. So answer must be A. Okay. Because when everything is 1, broadcast. When everything is 0, subnet ID. But don't change the other things. Only after the first part you are changing. Okay. Right. Third one. What is the network address of the network? So that is, you have to make all these 0. 1 0 0 0 0 0 0 0. So that is 1 2 4 8 16 32 62 128. 192 248 16 128. Answer is 3. A. How many IP addresses can be allocated to machines in this network? Right. So we have how many bits? 1 2 3 4 5 6. That means 2 to the power 6 bit patterns. 2 to the power 6 means 2 4 8 16 32 64. But we have to reserve 2 IP addresses. It has how many IP addresses that can be assigned? 64 minus 2 is 60. Okay. To machines we can allocate or how many can be allocated to machine? 1 2 3 4 5 6. 2 to the power 6 is what? 2 4 8 16 32 64. Sorry, 64. 64 minus 2 is 62, right? So the answer is 62 machines are there, 64 IP addresses, and we can allocate 62 machines. 4C. C. A web server on a machine X listen to TCP connection on port 80. Right? A web server on machine X is listening to the TCP connection on port 80. 80. It listen, that means web server. Okay. Another program pre-running on X want to send the UDP packet. with the source port as 80. So this is source port as 80. Okay. Which of the following statement is correct regarding the situation? Okay. So this is TCP 80. It is listening and it wants to send a packet with again port number 80, but UDP. Okay. To send the UDP packet with the source port 80. Which of the following statements is correct regarding the situation? Okay, let's take one by one. The program P will also receive message that comes to the web server. Right. If you are listening to the data, program P is which one? The web server on machine X listen blah blah blah. Another program P. That is another program P. Running on X wants to send UDP packet with the source port 80. Right. The program P will also receive messages that come to the web server. Yes, right. Higher level protocols may use the same port number by convention to avoid confusion. Yes, it looks like yes. I don't know. According to that answer, the program P will also receive messages that come to the web server. No, because the other program is using UDP. So therefore, if it is coming for the web server, it will be TCP connection, then it will be given to the TCP server, right? So therefore, let's not take that. Port 80 is a TCP port and therefore it cannot be used by P. I don't think there's something called TCP only ports and UDP only ports. Okay, so ports are ports. A port can be used by either TCP or UDP, right? The web server and P can send and receive messages on port 80. So that is what we found in Google search actually. A TCP 8 application can use TCP 80, another application can use UDP 80. Okay, so it looks like correct. TCP packets have a higher priority than UDP packets. So there's nothing called that, right? Because usually the priority is different. TCP means higher, not priority, higher reliability, right? Than the UDP, because TCP has the error checking connections, blah, 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 right? So let's keep it. Let's keep that. If the web server started first, then P cannot be started at all. No, because this one is TCP 80, the other one is UDP 80, right? I don't know, according to that explanation. Okay. So then we have to take the correct one as C. Okay. Question 5 is C. So just take it as a note, right? So that means it looks like the TCP 80 and UDP 80 is considered as two different ports. Okay. Right. 6. Select the application layer protocols that use UDP as the transport protocol. Right. So what you have to remember is the popular things are mostly TCP, like file transfer, email, World Wide Web. Okay. So very popular application that use UDP is DNS. Right, DNS. So HTTP definitely, HTTPS definitely, TCP, SMTP is email, POP is email. So they must be using TCP, right? So DNS is very popular application that use UDP because it's prefer the speed than the reliability, because anyway we are sending to multiple DNS servers as well, right? So let's see whether it's B. Yes, B. Okay. In your note, I have given you our note. I have given you set of application level protocols that use TCP. Easier thing is just remember which protocols use UDP, because the majority is using TCP anyway. So the easiest thing is try to remember which one is using UDP. That is the easier thing. 7. There is a TCP connection between machine M1 and M2. Right? M1 and M2. Client application name C on name 1. So M1 and name 2. There's a client application called C1 on name 1 and server application name S on name 2. Okay. Send and receive message over the connection. Assume that M1 and M2 have the public IP addresses. Okay, so they have the public IP addresses. What are the parameters required to globally uniquely identify the TCP connection? So in order to identify the TCP connection, you need the IP address and port number, right? So that is how that combination is the one that uniquely identify. IP address identify the machine, the port number identify the application. So it has to go to the machine and it must be given to the correct application. So that is something we discuss. The IP address and port number combination is the one that is needed. Okay. IP address, that is not good enough. IP address of N1, no. IP address of M2, IP address of M1, and the port number of the 2 points. Yes, right? IP address of M1 and M2 and the port numbers of the 2 points. So client also send a port number. So it says on the IP address. So I will go for D. 7, let's see. Yes, D. So we had this kind of a question last 2020 also. Actually, unfortunately, I never got a chance to look at that question. Okay, so we'll keep this, skip this one, okay, because I never got a chance to look at this question. Okay, just skip it for the time being. 9, TCP segment header does not contain. IP address has nothing to do with the TCP because IP address is something to do with the IP protocol, right? So therefore, so this is something we don't have it in TCP header. Port is always something to do with the TCP. Destination port, source port. I think this question was there in 2020 paper also, right? We need the check sequence number for reliability and the checksum for error handling. Okay, I think this is the exact question was there in 2020 paper. Okay, so I will go for A. A. The protocols used in the ping utilities. Right? I think this question was also there, right? I think the same question was there last year we found, right? Is it ping or trace route? I can't remember. I think the same question was there in the MCQ. Okay, so it is ICMP protocol. Yes, I think same question was there. ICMP. Okay. Right, address resolution protocol. So you can see this 2019 paper is something like a carbon copy of 2020 paper. Okay. Address resolution protocol is a protocol used by devices to configure the network interface. Not really, right? So that is to resolve your IP address and MAC address. Given IP address, you can get the MAC. Given MAC address, you can get the IP. Anyway, let's keep this. Is an application? No, no, right? ARP, I can't remember. Anyway, let's look at the others. I think it's a low level. Uses UDP as the transport layer protocol is not used by routers. Is used by to discover MAC address of an interface with given IP address. That is correct. That is correct. Because you can give the MAC address and ask to get the IP address. Okay, so that is correct. It's a protocol used by devices to not to configure. Then it is DHCP, right? Configure network interface means giving assigning IP address, etc. I don't think that it is a application layer. Right? I think it is a network or transport layer. I can't remember exact one. Just refer to your note. It must be there somewhere. Okay. All right. ARP is data link layer. So that means it's in the second layer. Okay. Second layer, layer 2. So therefore, that is not the answer. Is it using UDP? Just is not used by routers. So routers, actually, routers can use it, right? Because it can check the other IP addresses, MAC addresses of other routers, other devices. Actually, it's used by machines as well as your routers, right? I hope routers can use it. Definitely, the machines can use it. Usually, we ask it from the router. Right? Ask it from the router or network servers. So they have taken only E. So that means they have taken it as routers can also use it, right? Yes, routers, I think more than using it, routers used to help others. Okay, I don't know. At 12. So that is very easy question, abbreviation. I told you that these zeros can be abbreviated into two columns. It doesn't matter how many set, you just use two columns, okay? Because we know altogether this much and therefore this block contains this, okay? So therefore 8,000 colon, then rest of the stuff. That's it. Because there are no other zeros. If there are another zero block here, you have to write it as a zero block. You can't abbreviate that. So this is not an answer. This is not an answer. You don't have to write like this. Right? So this must be the answer. You can see just you have to write it only once. You don't have to write many times because we know that altogether 1, 2, 3, 4, 5, 6, 7, 8. So here 1, 2, 3, 4, 5. So therefore this represents three set of zeros. Okay, so that you don't have to write three set of columns. So the answer must be D. D. Select the most appropriate statement regarding the following. So it looks like IPv6 address because you can see the colon. 15. I think something that was mentioned in your slides. Okay. So we can write the IPv6 in V4, sorry, IPv4 in V6 format. Yes, it was there. Now let's this how a V4 has converted to V6. So I think this was mentioned. You just have the two columns and you just write the V4 address as it is. Okay, V4 address as it is. I think that was there somewhere in your slide. I can remember slightly. Okay, but I can't find the. Yeah. Okay. At 14, select the most appropriate statement regarding IPv6. Routers may fragment IPv6 packets. The source may fragment IPv6 packet. IPv6 packet maintains CRC checksums. IPv6 addresses are 48-bit long. No, 64-bit. It is not 2 times, 4 times. Earlier it is 32-bit. No, earlier it is 32-bit. Now it is not 64, 128. Okay. V6 is 128-bit. So therefore this is definitely wrong. IPv6 does not fit into any layer in the traditional TCP IP model. No, that is wrong. IPv6 is again IP. So that is wrong. At least let's remove answers. The source may, these three I am not very sure. But D and E looks wrong. Routers may fragment IPv6 packet. So fragment means you break it into a smaller packet. So there is mere fragmentation. Routers may fragment IPv6 packet. The source may fragment IPv6 packet. IPv6 packet contains CRC checksums. Okay. I'm not very sure about that, but it looks like D and E are not answers. Okay. So let's see the answer. 14. B. So the answer they have taken is B. Okay. The source may fragment IPv6 packet. Okay. Right. So just take it as a note. Okay. Right. 15. Which of the following statement is true regarding IP multicast? Right. Multicasting means you are sending it to multiple users, right? Like video conferencing, streaming, etc. It's not broadcasting. IP multicast is implemented on TCP. Is it implemented on TCP? No, right? IP, we discuss it under network layer, right? IP layer, right? Not under TCP layer. So let's keep it. IP multicast is link layer protocol. No, right? IP multicast means IP. IP means network layer. The intended recipient of the IP multicast packets are identified by multicast group address. Right? That we discussed, right? So if you want to multicast, we send it to a multicast group. And those who are in that group will receive it. So that is how multicast has been. It is in your note also, your UCSC note also, they have specifically mentioned that. Right? So we set it to a IP multicast group. So that is why you have separate IP addresses I think group class D. Class D is reserved for multicasting, right? So those can be used to multicast groups. So it looks like this is okay. All multicast packets must be acknowledged by the receiver. Receiver. That I'm not sure. IPv4 does not have multicast addresses. Right? IPv4 also have it. So that is why we have the group D. Right? Group D is there. Does not kill it, so therefore will not take it. So it looks like these are not correct because it's IP network layer. This is not correct because it says does not have. This I'm not very sure. Okay. So let's see the answer. So they have taken C. That means these they have not taken D as answer. Okay. They have not taken D as answer. 16. The bandwidth of a channel is right. So this you should be able to do it, right? So this kind of a question we did for the 2020 also. Just you have to apply the Nyquist formula, right? Log 2 1 plus SNR formula. Okay. 17. Communication system adds signal parity bit to every 7 bits of data it sends on channel. What is the purpose of parity bit? So parity bits are used to detect if there are any errors. It is used to correct errors. Oh. So that is the question I am also having. Is it parity for correction or detection? Usually detection, but I don't know whether if it is correction also we can call it parity. Remember we use Hamming codes. We say Hamming codes, right? Not Hamming parity bits. Okay, let's keep it. It is used to detect errors. Yes, definitely we can use to detect errors, but I'm just wondering whether if it is to correct errors, do we call it parity or something else? Parity bits are added to increase the bandwidth. No, right? Of course, the bandwidth can't be increased by adding parity. Data bits are encrypted using the parity bit. No, that is nothing to do with the encryption. So parity bits is to not to confidentiality, right? Not to others to confuse it. No, that is to detect errors and possibly correct errors. Parity bits is used for synchronization. No, for synchronization there are different things. Right. So I am not very sure about A, but definitely B is correct. Okay. 17. Right. So they have not taken A. So therefore just make it a note. When we say parity, it is for detect errors, not to correct errors. Right. 18. A cable consisting of copper wire in the middle surrounded by isolation material which in turn is surrounded by braided outer conductor. That is usually what they are talking is the coaxial cable, right? All these are in case in a protective plastic covering running along the cable. What is the type of this cable? So it looks like they are talking about coaxial cables, right? Because the braided outer conductor, blah blah. Outer conductor can inner conductor, outer conductor can. So is it B 18? Yes, right. So that is something we discuss and it is in your note as well. So just you have, I think they are just checking whether you know these words and braided outer conductor, etc. Right. 19. A sender is in a wireless network starts transmission to receiver R. So a sender S start transmission to receiver R this way. Another station X also start transmission at the same time. A sender S in a wireless network start a transmission to receiver R. Another station X also start transmission at the same time. S is within the range of X, right? So that is X is within the range of X, but R is not within the range of X, but R is not within the range of X. So these two are in the same range. Which of the following is the most appropriate statement regarding this station, this situation? Okay. So S want to send something to R, right? But S is within the range of X, but not with the range of R. I think this is hidden. I can't remember exact thing. දෙකක් කතා කරන්නේ අපි දෙකෙන් කොයි එකද මේකට අහු වෙන්නේ. So කොයි එකද මේක අත කතා කරන්නේ? Either it must be hidden terminal problem or exposed terminal problem. We need to transmit to A, and A and C need to A and C needs to I think this one, right? Because we want to transmit to A, but B and C are in the same range. So therefore, it can be exposed terminal, because when C want to send something, you will feel like the network is busy. R receives the combined signal from X and X. R receives the signal from X after signals from S. R should send a message to X requesting to stop the transmission. The signal from X changes the signal from S. Okay, so let's see the answer. I am not very sure what is that. Okay. 19. Let's see the answer. A. R receives the transmission from S without any collision. I think that is reasonable, because there can't be any collision, because X and R are, though S and X is connected, but X and R are not in the connectivity. So therefore, there's no possibility of collision here, right? There's no possibility of collision here because X cannot reach R. I think what they have mentioned is that problem, right? Exposed node problem. Unnecessarily, S has to worry about this, but in reality, it doesn't have to worry, because in reality, because S doesn't know that X has no connectivity with R, right? Because what S know is S can reach X, but S doesn't know that X cannot reach R. When X cannot reach R, there is no way of collision, right? So I think that is why there is the answer. At 20, consider the following statement regarding wireless network. Wi-Fi networks interfere with cellular GSM networks. No, right? Wi-Fi can interfere with some other networks, like remember that garage and blah blah blah. Bluetooth වගේවත් එක පුළුවන් නේද? But I don't think GSM, right? එහෙම තියුන්නේ නැහැ note එකේ. ළඟ ළඟ තියෙනවත් එක තමයි interfere වෙන්නේ. Wi-Fi networks may interfere with Bluetooth. Yes. ඒක කෙලිම note එකේ කියලාම තියුණා. Right. Wi-Fi operates in ISM bands. Yes, Wi-Fi has given some ISM bands, and unfortunately some of the ISM bands are shared. So 2 and 3 the බලන්න උත්තරේ. Yes, E. Okay. I think this question was there last 2020 also. මේ question එකත් මට හරියටම sure නෑ. හරි මේකට මොකද formula එකක් තියුණා. If I get a chance to look at it, I will look at it. Okay, but එකපාරට ඔලුවට එන්නේ නැහැ මේක formula එක. හරි. ඒක චුට්ටක් තියමු. 22. Which of the following statement is true regarding VPN? An isolated physical point-to-point link is required for VPN. Right? No, you don't need physical point-to-point link. Right? VPN use the shared public internet. No, definitely no. B, a VPN transparent to user software. A VPN is transparent to user software. I'm not sure. A special hardware interface is required to connect to VPN. VPN not a special connection. It's a software level thing, right? So VPN Facebook. ISPs do not provide VPNs as a service, and end users must establish their own VPNs. Of course, we can establish our own VPNs. Maybe they provide, but I don't know. I'm not very sure. Okay, but hopefully they are providing also as a value-added services. Okay, that I'm not sure. It is not possible to establish VPN between two remote offices if they are connected to the internet through different ISPs. No, there's no such issue, right? We don't have to have the same ISP provider to create a VPN connection. Right. So it looks like ACER Rome. I'm not sure, right? Maybe C, maybe B or D are correct. Okay, let's see the answer. So they have taken only B, they have not taken D. VPN it means VPN is transparent user software. So that means we can say that this particular connectivity is with VPN and this one is not with VPN, something like that. That is mean by transparent. And they have not taken D. That means IPS do not provide again. So that means ISPs can also provide VPNs. Okay. Maybe some ISPs are providing that. At 23. Which of the following statement regarding DNS is not true? Right? Not true. A. There can be multiple MX records associated with a single domain name. Yes. So that is, I think we discussed, we got that kind of question. The final year student again. Discuss. So MX entries are for email. Emails, okay, configure email servers. So you can, yeah, I think I discussed that with the final year students. They have the system and network administration. So anyway, so MX records are for the email, and if you we can have multiple MX records. So that means if this particular email server is down, anyway the email will be sent to the other email, because email is when others are sending. If our email box is down, they will receive a message saying it is rejected. That is not good, especially during transitions and other things. We configure multiple email servers, and also there can be situation where email server is down. So then rather than the sender getting error message, your email will be sent to the other email server. So then your client can sync with multiple email servers. Okay. So yes, man. Multiple MX records in the පුළුවන්. හැබැයි අහන්නේ not වහන්නේ. Not no. So what we need is not, so this is not an answer. A PTR record associated a name with IP address. Pointer is no. IP address eකට connect කරන්නේ A or AAA. Right? A is IPv4 address. AAA means IPv6 address. Okay. Pointer එකක් දාන්න ඒකට නෙමෙයි. හරි. So that is wrong, right? PTR record name with IP address. The record type A maps IPv4 address name. Yes. Record type A maps IPv6. Yes. It is not possible for two names to resolve to the same IP address. It is not possible for two names. නම් දෙකක් එකම IP address එකට එන්න පුළුවන්. මං හිතන්නේ පුළුවන් කියලා. හරි. නම් දෙකක් එකම IP address එකට එන්න පුළුවන්. Yes, because that is not issue, right? Because say I think even in your case, bit.lk is going to your BIT server. Then there's something called bit.cmb. Blah blah blah. That is also getting into the same server. Yes, you can do it because it's not issue. It's not issue. Okay. But it says it is not possible, so therefore that is wrong, right? So B and E. 23. Oh, they have not taken B. PTR record. And PTR record IP address එකට දාන්න කියලා. PTR තියෙනවා. Point alias for an yes. Alias for an IP address. So that means yes. So it is a it is also point to ඒකම දැන් open start. මම කලින් දවස් තුනින් දැන් බහතියි. Right. So that is yes. That is also point into a IP address. Right. So 24. An organization has a single public IP address, one IP address allocated to it. it wants to allow 10 users. That means you have to go for either network address translation or port address translation. Okay, 10 users in its LAN to access the access websites. These users usually access the same set of websites. If they are accessing the same set of websites, you can't go for network address translation, right? So then you have to go for port address translation. What is the most appropriate technology devices that organization should be used for this purpose? HTTP proxy, firewall, L2 switch. I don't think switch is going to work for that. Firewall is a security device. DHCP server, no, DHCP server is just assigning IP. What we need is port address translation. Network address translator is not going to work because usually access the same set of websites. So if both two machines going to the same site, NAT is not going to work. Okay, so therefore that is also not working. So what we need is port address translation. I'm not sure whether HTTP proxy server can do it, but maybe, because other answers are wrong. We need something high level because port is a high level thing than IP address as well. Okay. So anyway, it's a good point. So which network device can do NAT? NAT that means router. Router can do NAT. Okay. Is done. Is then making the corresponding entire NAT generally operates on router or firewall. Firewall, right? Even firewall can do. So ekat note karagana then pat ahala dinawa ke NAT ilangata. So that means router can do the NAT. Okay. Do firewalls do the NAT? Network address translation is not a type of firewall, rather it is a function performed by firewall. Yes. So that means because they have asked about the PAT, right? So network address translation can be done by routers or firewall, right? Just check whether anything else also can do it. So then what about the PAT? According to the answer, it says proxy server, okay? Do home routers use NAT or PAT? So home router එකක් නැහැ NAT වෙන්න ඕනේ. But anyway, I can't get it from the search, but according to the answer, right? But if you go by the answer, the PAT can be done by proxy servers, right? Proxy servers. So let's take it as the answer and just note it down. And anyway, you can do a double check, okay? By doing a Google search again. Because examiner can ask, right? Final question. What is the most appropriate statement regarding unshielded twisted pair? UTP, right? So UTP is the basic thing where it's low quality thing for basic core where you don't need a lot of high speed, okay? Category 5, cables have more twists per inch than category 3. So usually higher the category, higher the twist. Higher the category, higher twist. And when you go to higher categories, unshielded becomes shielded also, right? Because shielded is better. UTP unshielded category 5. But yes, when you go for higher the category, higher the number of twists. Okay. Unshielded the category 5 and shielded. Right, next one, UTP cables do not radiate any electromagnetic energy at all. Especially unshielded, but you can't say that nothing is radiated, so we will not take that. UTP cables are not affected by interference from nearby. No, so they are highly interfered. Home user cannot get ADSL service if UTP cables are used. No, there's no such thing. UTP cables can be used. The only reason to have twist in UTP cable is to strengthen the cable. No, not just to strengthen the cable. It is to reduce interferences and crosstalks and those things. Okay. මේකේ අග කොටස නම් හරි මට මුල ටික මතක නැහැ මෙයා UTP ද කියලා නම් හරි what is the answer yes A පොඩ්ඩක් බලමු category 5 UTP ද කියලා මෙතන දෙකම ඕනේ දෙකෙම තියෙන පුළුවන් මම හිතන්නේ පොඩ්ඩක් double check කරගන්න ඒක නිකුල answer එක දෙන්න right so that's all about the MCQ so next we have the second paper okay අපි second paper එකත් අක්කල කරපුවා second paper එකට එච්චර වෙලා යන්නේ නැහැ right draw a diagram depicting the components of an ADSL network indicating the equipment at the ISP and the home okay ISP and the home so you have to I think this diagram was there in your note also right you have to have that splitter the ADSL එක එන්න ඕන splitter එක තියෙන්න ඕන one then the computer side you must have the router right router අනිත් පැත්තේ අර මොකද්ද loops එහෙමත් ඒකන අඳිනවා හැබැයි යා ඒ පැත්තේ තියෙනවා මොකද්ද දෙකට බෙදෙන එකක් යනවා ටෙලිෆෝන් ලයින් එකට අනිත් එක යනවා ඉන්ටර්නෙට් ලයින් එකට ISP එකේ පැත්තට හරි yes you can see so that is also called splitter right that is also called splitter so here also you have to draw the splitter and this side we have to have the modem so that is very important splitter split card passe thamai modem ekata ganna ona ADSL modem ekata so then it goes to the computer so this is connected to the telephone so this side also there's a splitter one is for the audio the voice patta mehata yanawa me pattata enawa ISP ට යන එක නේද DSLM කියලා දාලා තින්නේ just remember that also right what is DSLM digital single lens mirrors what is that DSLS කියන්නේ මොකක්ද කියලා DSLM නේ වෙන එහෙමත් නම් පාවිච්චි කරනවා නේ මයිකල් මම දැන් Google search එකට ආවෙන්නේ නැහැ DSLA එකයි එන්නේ digital subscriber line access multiplex so that is the one that is they are using right DSLA that is for the ISP multiplex කරන්න කරන්නේ right so what is the reason to have asymmetric high downlink and low uplink bandwidth in typical ADSL connection given to home users? That question is very easy. So typically home users do more download and less upload because they are not having web servers or whatever, right? So they just consume videos and other things. So therefore, so we have the higher, that is why we call it asymmetric, okay? Right, so that is correct, right? C. The equipment commonly named as router at the home end of the ADSL network is much more than a router. Yes, your router can have the DHCP server, it can have a firewall, right? It can have firewall and now we found that it can even do the network address translation. And I don't know whether it can act like a proxy server, but definitely the other things. The equipment act as a ADS, it can act like ADSL modem also, right? Because it says ADSL network. NAT, NAT so network address translation can be done by router, right? A DHCP server and also gateway. Right? Proxy server so that need additional things. Okay, but I think some routers have the proxy servers also. The machine on ADSL home network IP address, an IP packet sent from the network has reached a server, but the source IP address packet found to be this. So that means definitely network address translation, right? So your router or the network server has changed to the different IP address. Okay, or else stand to be this. Yes, what is the possible cause for the difference in IP address? Yes, it has to be either network address translation. It can't be port address translation. Even it can be port address translation also. In port address translation also, we give our common IP address and different port numbers are assigned to different machines. So I think it can be either network address translation or port address translation. Even in port address translation, we give the IP address of the router or the other end, okay, proxy server. The IP address of a machine is private IP. Private IP 168 private IP. The machine is connected to a public network through NAT box. So it says network address translation, not the port address translation. And it must be 192.248.16.99. So this must be a public IP address. So the private IP address range and private range get there. An organization decides to change its web server www.bit.lk. It also decides to keep the current web server with its current IP address. So that means so they are mapping it to www1bit.lk. So that means they are having a new server and old server. So this is www.bit.lk. Old server they have mapped it to a www1.bit.lk. Okay. The network administrator to change the DNS A record that is to mapping to IP address to www.bit.lk to point to the IP address of the new server. Right? I make a new server. And the A record of www1bit.lk to point to the IP address of the old server. So the old server IP address is mapped to this one. Another A record. Two A records are there. Okay, because there are two domain names. Users who tried to connect to www.bit.lk immediately after this change complains that they still get the content from the old server. So that might be possibly the IP. These migrations take usually up to 48 hours. Right? Because when you set it, it has to send to the DNS servers all over the world. Right? So usually it takes up to 48 hours, that is up to 2 days sometimes, to migrate it to, because not all the DNS servers accept those things immediately. So they have schedules, right? So then they migrate to the next level. I think that must be the reason. I don't know. It looks like because they have configured the 2A reports, right? They say DNS records are cache. Okay, cache වෙච්ච හන්දරු එන්නේ. ඒ කියන්නේ migrate වුණා cache invalidate එක නැහැ. හැබැයි අර කතන්දරෙත් හරි හැබැයි මම හිතන්නේ ඒක දාලා නැද්ද? Therefore the name resolution query because definitely when you change the DNS value entries, it takes time to migrate those things, because now the new, this must be pointing to the new IP address. So I think that must be also answer, but this says a DNS record is cached on a DNS server or maybe user's machine. Okay, so that is also possible, but I think other answer is also valid. Okay, so this one is says that it is coming from cache, but anyway DNSs are cache also, but they should be the DNS servers usually invalidated periodically. An organization has decided to use a mail server provided by cloud service provider. The provider has already agreed to provide the service and has given IP address of the assigned mail server to the network administrator of the organization. The organization also wants to keep the current mail server running as well to receive mails in case of failure in the cloud server. Describe the changes required in the network infrastructure and service to ensure that all mails for the organizations are sent to the new mail server. Okay, so an organization has decided to use a mail server provided by the cloud service provider. So that is new server, right? The provider has already agreed to provide the service and given the IP address. IP address that means you need to have configure a MX record for that. The organization also want to keep the current mail server. Actually, so that means now emails are coming for your domain. Say, for example, our one is Aurora CSL. Okay, so emails are coming for our domain. So then it is sent to the, in our case, our emails are connected to the Google servers. So likewise, we have to configure. Now, we want to send it to this server as well as this server, right? The organization also wants to keep the current mail server running as well to receive email in case of failure to the cloud server. So you can have multiple MX records. If you have multiple MX records, what happens is, first it will try the preferred one. But if it is down, it will try the second one. So therefore, you don't lose the email. But this will be almost all the time used. But in case of a failure, it will come here. Okay. So you should, then what you are supposed to do is add two MX records to the same domain. And this add this one as the higher priority one, add this one as the lower priority one. Okay, I think you can set up the priority value. Two MX records are needed. One MX record of the DNS record for the organization should point to the new email server. Another with low priority. Yes, you can have the priority. The low priority should be point to the all server. So high priority one, because that is what we need. But the low priority one will be used if the high priority email server is down. Right, third question. The machine X is on LAN L1 and machine Y is on LAN L2. මේ වගේ question එකක් තුනේ 2020. මේකම මම දන්නේ. Machine X is on LAN L1. LAN L1. Machine X. Machine Y is on LAN L2. Machine Y. Right. The MAC address of the X is MX, right? MX, and the IP address is IPX. Similarly, the MAC address of Y is MY, and the IP address is IPY. Okay, IPY. The gateway R is on both L1 and L2. L1 L2 ට එක gateway එකක් තියෙන්නේ. connect කරලා ඇති gateway එක හරහා. Both L1 and L2. R's interface on L1 is R1. මොකක්ද R's කියන්නේ? R කතාවක් කොහෙවත් තියෙනවද? Gateway R is on both L1 and L2. R's interface on L1 is R1. L1 පැත්තට ඉන්න interface එක R1. This is R. With MAC address MR1, R1, MR1, and the IP address is IPR1, IPR1. R's interface on L2, this side. I think this question was repeated question. L2 is R2, R2. With MAC address MR2 and IP address IPR2. මේකම ඔය වගේ මට මතකයි කියලා තියෙන 20 paper එකේ. There are no other gateways on L1 and L2. That means they always has to go through this. Okay. And IP packet P is sent from X to Y. IP packet එක කනවලු P කියන එක X කින් ඉඳලා Y ට. මේක හරහා gateway එක හරහා යන්න එපා. What is the source MAC address of the frame that contains P when it reaches Y? Y reach වෙනකොට source MAC address එක අහන්නේ. source MAC address එක වෙනවද මොකද්ද? මෙයාගේ MAC address එක නේද? මොකද MAC address ගලව ඊළඟ තමන්ගේ එක දානවා source එකට destination එකට දානවා තමන් connect කරලා තියෙන ඊළඟ තැන නේ. IP address තමයි වෙනස් නොවි යන්නේ. net එකක් කරා ගියොත් විතරයි වෙනස් වෙන්නේ නේ. So therefore the source when it reach Y, the source MAC address must be MR2 නේද? MR2 වෙනවා. Yes, MR2. What is the source IP address of P when it reaches Y? Source IP address will be still this one. IPX, assuming that it is a public IP. කියලා නෑ නේ මෙයා IP address ගලවනවා කියලා නෑ නේද කියලා තියෙනවා. නෑනේ. So then we'll take IPX කියලා නෑ නේ IP address translate කරන්න. So we'll take IPX. Yes, IPX. There is no reason to change the source IP because they have not mentioned anything like that. Okay. What is the destination MAC address of the frame that contains P when it leaves X? My questions ALLICD paper එකක් තියෙනවා හරි. What is the destination MAC address of this frame that contains P when it leaves X? Leave කරනකොට destination MAC address එක වෙනවනේ මෙයාගේ MAC address එක නේ. මෙතනට තමයි ආය යවන්න ඕනේ ඉස්සෙල්ලා. MAC address R1, MR1. Right. And that's it, right? Yeah, that's it. Right. So we did 2 papers, right? So I hope you can manage the other papers. Okay. So if there are any questions that you want, they have not asked subnetting questions. No, subnetting questions are there. So I'm very sure this year they will ask a subnetting question. So if I'm subnetting කරපු දවසේ recording එක බලන්න මතකද අර ඉස්සෙල්ලා ලොකුම sub network එක හදන්න ඕන. හරි. bit ගානක් දීලා ඊට පස්සේ ඉතුරු වෙන එයාට 1 දුන්නොත් 0 set එක අරගෙන අපිට තව කඩන්න පුළුවන් දැන්. හරි. මොකද ඉස්සර දෙන්නේම subnetting. ඔය අවුරුද්දකට කලින් හැමදාම දෙන්නේ subnetting question එක. හරි. එකක් දෙනවම තමයි. හැබැයි පහුගිය අවුරුදු දෙකේම subnetting දීලා නැහැ කියන්නේ ඔයගොල්ලන් බොහෝ ලොකු chance එකක් තියෙනවා subnetting question එකක් දෙයි. හරි. එක එක size වලට කැඩෙන්නත් දෙන්න ඉඩ තියෙනවා. හරි. අනිවාර්යෙන් බලා ගන්න note එකෙත් තියෙනවා. Right. So we'll stop the networking subject. Okay. So we are going to take a break. After the break, we have one more topic that is a small topic. It won't take more than half an hour. But we take a break and do that one. That is socket programming, right? Yes. So we'll do that one, right? We'll take a break. Then we have another. We'll do another half an hour to 1 hour session. Okay. Okay. So now let's finish our final topic. Okay. On the mid enterprise application. So then that subject is done. Right. So last time we discussed web services and JSON. Of course, this one we don't have to do anything. That is how to set up your environment, right? So therefore, we don't have anything because we have already set up the environment and we have done. So nothing at all here. You can just go through the note anyway. Right. Web sockets. Web sockets. For that, I wasn't able to finish the note. Okay. Because, but anyway, I will give you a link to a tutorial. So that is good enough for you, right? So that is good enough for you. And I'm going through that tutorial. Right. And again, we are using Tomcat because I didn't try that. I asked you how to configure Tomcat parallelly with the JBoss or the other server. So therefore, it must not be issue. right? Wildfly. So same Tomcat, you don't have to configure it again. So this tutorial is again working for the Tomcat 10. Okay, Tomcat 10. Right. So I will go through the note. Then I will explain you a few things about the first. I will explain you how to do a practical example. So WebSocket means basically a connection to a server. But that connection can be even from a client, just like a web service, right? Even a Java client can create a connection to a WebSocket connection. So which is little bit advantageous as well, because you connect and you disconnect. Okay, connect and you disconnect. Right. Anyway, we'll go through the theory part. Anyway, let's first go through the theory part, then we'll come back, we'll do the practical. Okay, otherwise you don't know what we are doing. Okay. Let me open the WebSocket. Okay, I will go through halfway, then we'll do the practical, and then we'll again go through the rest of the stuff. Okay. And WebSocket. So this topic discuss the WebSocket and develop a simple WebSocket using Java. Intended learning outcomes. At the end of this lesson, you will be able to explain the behavior of a WebSocket. Explain the behavior of a WebSocket. Compare WebSocket with HTTP. So that is another thing. Because we use HTTP in web services, right? Last time we developed a RESTful web service. So there we use HTTP. How to implement a WebSocket. So we are going to do practically how to implement that. List of subtopics. Develop a WebSocket server endpoints. WebSocket server endpoints. Developing a WebSocket client. So then how to use a client to connect to the WebSocket. Not through HTTP, right? WebSocket is not HTTP. The web services use HTTP, right? Servlet use HTTP, right? Right. So clients can establish lightweight connection with the server. So with WebSocket, we establish a lightweight connection, right? Which does not take much bandwidth, resources, etc. And another thing is we can do bidirectional communication. You know that client-server architecture is not bidirectional. Client request and consume, server serve. Server can't proactively communicate with the client. That is why two different things, client and server. But WebSocket is bidirectional communication. You can send X to Y and Y to X also. So we are going to create that kind of socket. So servers can push data. So that is not something that you can do with HTTP. Servers cannot push. Server can only serve. Right? But WebSocket, you can push data. So WebSockets are heavily used early days in public chats. There was Java-based chat before WhatsApp and other things came. Now, of course, we have the WhatsApp, Viber, and all the other things to chat. But early days, we never had something like that. Of course, we had the Yahoo and MSN and things like that. But at that time, for public chatting, people use Java-based, applet-based chat software. So they all use WebSockets. Okay, because it has to do two-way communication. When someone chat, he can send it, and when someone else chat with you, they have to push it. Actually, you can create a, not in this exam, a cinema, yeah. So you can create a simple Java chat application using the WebSocket concepts. Okay, right. So it's a bidirectional communication, and the server can push the data to the connected clients. Server can push the data. So that is why, especially in something like chatting, say this one client, this client, so that client said it here, then these clients push it to this client. So then when this guy reply, you get it and you push it to this guy. And of course, right? So those kind of facilities are there in socket programming. Once the connection is established, the client and server can send simple information between each other without reconnecting. Connection can be destroyed when the client or server decides to do so. So we can keep the connection open, and at any time both parties can destroy the connection as well. So this is an example. They have taken auction. So I just took the chat application. So auction is also like chatting. Okay. So we are bidding, and bid has to be reached to the other party, etc. Auction items are posted in the website. Users can place their bids on items with the given time. The item will be sold to the highest bidder. So that is another very interesting application you can build using WebSockets. Okay. So therefore, the user needs to view the current bid at all time. Current bid means the highest bid. So it's not you are just looking at the website, right? Website, unless you are refresh, you don't get the new things. But of course, now we have the Ajax and other things. So therefore, the WebSocket programming is not the only way to do these things. Now we have the Ajax technology as well. Right. So let's assume that this site need to refresh the price every 2 seconds. Right. So every 2 seconds, we want to refresh it because new bit might be there. For 1 minute, there will be 30 updates for single user. If you do it like a web HTTP, there will be unnecessary refreshing. Why? We don't know whether the bit has changed. But if we can push only when bit has changed, that is more efficient. So in order to do that kind of thing, we need WebSockets. Okay. So with WebSockets, once the connection is established, only the information will be sent without repeating the headers and other things. Okay. Right. So this is the difference between HTTP and WebSocket. HTTP is unidirectional. Clients can send requests to the server and server response. And it is stateless. It's response, serve and forget. Serve and forget, unless you are doing session handling. So when a client sends HTTP request, TCP connection opens, and after sending the response, the connection closes. If there are 10 requests, 10 TCP connections are needed. So you create a connection, send the response and close the connection. Again, next time, again create a connection. WebSocket, that is HTTP, bidirectional, full duplex communication. That means we can send like this and receive like this. And it's a stateful protocol where you can keep track of each and every connection you are having separately. Right. And we use this TCP connection again because we need some reliability. So how to do that? So there's something called open handshaking. And then the open handshaking response. So then the connection is established. And then you are in a communication session. So when you are done with the communication, you can terminate the communication. Any party can terminate, initiate the termination, and then the communication is terminated. Okay. Right. So this is an example they are doing. Actually, we are going to do this exactly same example. I mean, not the coding wise, but the functionality wise. So we are going to have a server. It is just a web server, which is going to act like a socket server. And we are also going to use a browser to send a message and get the echo. From the socket or the server. And we are also going to use a browser with JavaScript code to do that. So we are going to do the exact same thing, but the coding will be slightly different because I took the coding from a separate tutorial, not from your note. Okay. So first of all, you have to create a project. Okay. So that part, let's do it. Right. I have partially finished the node, but I have not finished it. Okay. So first you have to create a dynamic web project, just like we did throughout the syllabus. Okay. Just create a dynamic web project, give it any name, and make sure your target runtime is Apache, right? Tomcat 9 that we use for REST web services as well. Nothing fancy, just create the dynamic web project. Then create a Java class. Now I will show it. don't create a servlet because we are going to do a socket programming. Now I have created a dynamic web project. Right? So just simple web project. You don't have to convert it to Maven or anything because we are not going to do any libraries, special libraries. So just create a dynamic web project, right? Then go to the Java resources, src, and create a Java class, new class. Okay. So that's it. And give it a package if you want and the name. So in our case, we are going to call it socket server. You can give any name and just say finish. This is just a normal Java class. Okay. So then add this code. I will explain the code later. Okay. Add this code. Now I already have that code added. We call it web server Java. Right. So then you don't have to add any libraries. These are all available in the runtime as long as your Tomcat is your target runtime. So you don't have to add any jar. So this is just a class. Okay. And I have added few methods: on open, on close, on message, okay, and on error. So those are the methods that will be called during your life cycle, and we are more interested about on message. And you can see that I have set up a just like Java RX web services. We are using annotations to denote that it is a socket. Right? So this is ampersand server endpoint, and this is the URL for the URL pattern. Okay, so therefore our socket URL is going to be our dynamic web project name. In my case, WebSocket demo / WebSocket point. Okay. And these methods also must be having the annotation: on open annotation, on close annotation, on message annotation. It is the message, the annotation that matters, not the name, right? Name not command annotation on close on open on message on error method number use number use and on error. That's it. And me annotation use import they are all in Java X WebSocket package. Java X WebSocket package. Right. So then, so that is going to act like a WebSocket server. So then we need a consumer. Right. So go to the web content, right click and say new HTML file or JSP or whatever. HTML is okay. So add a HTML file and add this code. මම code එක share කරනවා ඔයාලට. code එක share කරන්න. code එක මට share කරන්න දැන් නෑ code එක අර tutorial එකේ තියෙන code එකම තමයි මේ තියෙන්නේ. Exact code. Right. So there what we have done is UI wise මම JavaScript කාලේ පස්සේ explain කරන්න. UI wise we have added a form එකක් add කරලා දිනවා. So it has a input text field for message, right? Text field. Then we have a button, right? And another button. Two buttons are there. They are just button, not submit buttons or whatever. This is also button. This is also button. So why we are not having submit button, though it is a form, we are going to, rather than doing a get to post HTTP submission, we are going to call a WebSocket. Okay, WebSocket එක call කරන්න හදන්නේ මේ data එක. ඒක අපිට මේ submit button එක දැම්මේ නැත්තේ. මෙතන වාට වෙන method එකකුත් නැහැ, form එකේ action එකකුත් නැහැ. Right? Method එකකුත් නැහැ, action එකකුත් නැහැ. So we are going to just call it using a socket, WebSocket. Okay. So I will explain the rest of the code later. So now you should be able to, once you have that HTML and Java file, that's it, nothing else. And you don't have to do any changes to not anything or web XML or nothing. You don't have to do anything. Just create this Java class, add this HTML, then deploy it. Server එකට add කරන්න. මෙතන ගිහිල්ලා Tomcat server එකට add or remove කරලා ගිහිල්ලා add කරන්න විතරයි තියෙන්නේ. Restart කරන්න ඕනේ නැහැ මේකෙදි. මතක නේද මම restart කරන්න ඕනේ කියලා ගොඩක් කරාට web service එක වැඩ කරද්දි මේක දින restart කරන්න ඕනේ නැහැ. Usually it works, but if it is not working, better restart and see. Right now, I am going to start my server because I already have deployed the webs of this one. Right. So I'm going to delete these two and add it again. I'm going to add the WebSocket demo. I have built the project. So let me restart the server. Right, so no errors. Right, now you can call the this particular page HTML page from මෙතනින් ගන්න ඒතර මට URL එක ගන්න පුළුවන් run as කරලා. So then I can get the URL. Right. Then I'm going to take it to a browser. So this is small window. Right. So this is the UI we created, right? Text field, 2 buttons, and HTML එක තව text area එකකුත් add කරා. යටින් හැදලා දාලා තියෙනවා text area එක. So this is the text area. Okay. So that is used to get the response. Get the response එක ගන්න. Right. So now I will just show you how it works. Say type something like say Amal and just click on echo button. So then using JavaScript we are creating a socket connection with the server and calling it. Okay, and we are sending this text, and the web socket is going to read that data and send it back to us. Okay, us to this page. Okay, you can see that this is the response I got. Message sent to the server, message received from the server, echo from the server Amal. That means we have received the same message from the server as well. And of course, at any time you can disconnect as well. Now you can say it's disconnect. And if you want to again send it, when you refresh it connected, right? When you refresh it can connect, say Kapila. So this is the echo we are getting from. That means the word Kapila is sent to the server as a WebSocket connection. Then the server send the same thing. Okay. And also in the console, we are having a system out println. Okay. So you can see message from the client is Kapila. Earlier message from the client is Amal. And also you can check whether connection is created, connection is closed, etc. Okay. Now you can see it is Kapila. I will clear this. Now I am going to submit it again. Say Samat. So message received as Samat. And you can see message from client is Samat. It's not a new connection. The connection is already there. Right? We are now in a communication. Right. So let's look at the code a little bit. Now this is self-explanatory. We have the open method, not this name. This one is the important. This can be any name. On open method, on close method, on message method, on error method. So when a connection is open, this is this is called. Okay. I will page refresh karo tara connection nak hadeda. Open our connection is closed suna alut connection nak haduna. So that is open connection. So these methods are automatically called. Right? When you are closing the connection, you can see close connection. And when you receive something, on message is called. When we on message again echo from the message from the client here. Message from the client. Right? So when a connection is closed, this one is getting called. When connection is open, this one is getting called. And also you have the on message for any other thing. And here we never got an error. If there's an error, this will be called as that. So that's all about the server-side code. Right? Of course, you can add other features. Now, if you look at the client side, we have the form and text area. Okay. And this is not in a function. This will be initially happen. When you refresh the page, this will happen. Okay. This will happen. Automatically, this JavaScript will be called. So this is how you create a socket connection. So you have to create a WebSocket object, Java object, and you have to send the URL with WS : just like HTTP WS. It's a different protocol. Then localhost 8080 WebSocket demo. That is my project name and the endpoint name. Abhi daku endpoint name ekata oy thiyena. Metan daku endpoint name annotation. So this one. Okay. That is how you create a socket object. So sorry, this is not Java. This is JavaScript. JavaScript object ek hadiwe. Okay. So then you can create a connection WS open, right? Then you can see on open, on message, on close, on error, right? We are calling them different methods, right? So these are the JavaScript functions. So this is the echo text on open, on close connection. We are closing the WebSocket connection, get message, and this is close and send message. Okay. So these are all JavaScript functions. JavaScript functions. And here we have the form, and when you click on this, we are calling the WS send message, and here WS close connection. So WS send message is a JavaScript function we have written. This one. Since we have the WebSocket object above this one, we have a method called send. Right? We have a method called send in the WebSocket object in JavaScript object, and we are sending the message value. Message value means message is object, its value. Right. So likewise, there are methods that you use to call your WebSocket connection. Okay, now let's go through your note again. Right. So this is what we demonstrated. Right. So they call it echo server Java. We call it socket server. And make sure that you have the server endpoint annotation. Right. Server endpoint annotation. And this will be your URL path. Your dynamic web project name / echo in this case. Right. And this is now this method can be any name. Only thing is you must have the proper annotation. So this one is only having the on message, and it is getting that as a parameter, and it is sending it back, returning. Return when ekata socket එක යන්නේ එළියට ආයේ. Right. So server endpoint annotation, on message annotation. Of course, then you can compile it. So we are using, we are just building it using the Eclipse. Okay. Right. So then if you want, you can create a client as well. Right. So this client we created using HTML. This one also using creating HTML client. And we have the HTML client our functionality. And of course, this is our form. මෙයා div එකකට පෙන්නන්නේ අපි පෙන්නුවේ text area එකට නේද පොඩි වෙනසක් තියෙන එච්චරයි. Right, so you start your server, web server, and this is the UI for your example. Our example is a little bit different, and we are getting the echo in the value. එයා පෙන්නන්නේ div එකකට දාලා පෙන්නන. connection error එකක් එන්නත් පුළුවන්. server එක down කරලා බලන්න කියලා දෙනවා connection error එක එනවා කියලා. හරි. server එක down කරලා. එක් කරලා බලන්න. handshake එක බලන්න නම් ඔයාලා tool එකක් දාන්න වෙයි. tool එකක් නම් මට හොයාගන්න බැරි වුණා. මම එතන try කරේ නෑ tool එකක්. මේ මොන tool එකෙන්ද බලන්න මේ අරන් තියෙන්නේ මට හොයාගන්න බැහැ මොකද tool එක කියලා. curl එකෙන් බැරි වෙයි නේද? ඒක නම් sure නෑ මොකද මෙයා පාවිච්චි කරලා තියෙන tool එක කියලා. ඒක කියලා නෑ. So this is what happens initially. Handshake request is sent and handshake response. Then connection is established. So that is what happens initially. Right? When we connect, refresh කරත් තමයි ඒක වෙන්නේ අතට. අපේ ගේ නම් refresh කරද්දි තමයි connection එක establish වෙන්නේ. So අපි connectivity හදන්නේ එතන. So then you can send all your WebSocket, okay, on message methods. Message events are there, open events is there, error event is there, and close event is there. Open event, close event, message event, and error event. Okay. නම මොනවාද දැම්මත් කවන්නේ නැහැ. annotation එකෙන් තමයි අඳුරගන්නේ. නමට ඕන දෙයක් දාන්න පුළුවන්. Right, so this is what happens. Connection is established, and finally connection is terminated. Okay, so in between you can have messages, etc. Message එකේ ඔයාලට error එකක් එන්නත් පුළුවන්. ඉතින් අනිත් පැත්තෙන් if there are issues, so server down or something. On open, on message, on error, on close. Okay. Right, so server side you need either web container or EJB container. So what we used is the web container. That is why we use Tomcat. Okay. So it says it can be done in EJB container also. I can Wi-Fi එක તો වැඩ කරයි පොවිට. තමයි server එක මාරු කරුවම වැඩ කරන්නත් ඉඩ තියෙනවා. හරි server එක මාරු කරලා deploy කරලා බලන්න Wi-Fi එකට වැඩ කරනවා. මම බැලුවේ නෑ. You can see you can have a socket connection with either a web container or EJB container, but EJB container also I think you have to get it from web container, right? Web container එක හරහා EJB container එකට කරන්න. ඒක නම් කියන්න. Yes, web socket endpoints are placed in the web container. You can't directly communicate with the EJB container. You have to communicate with the web container. Of course, the web container can communicate with the EJB container, right? Right, your socket app can communicate with the session bean or something like that. I think that's it. Right, so share web application status. HTTP session object represents the sequence of HTTP interactions from the same HTTP client. Now remember we have something called HTTP session, same HTTP client. WebSocket connection begins with the opening handshake, and because the opening handshake is an HTML interaction, HTTP interaction, Each WebSocket session object is related to HTTP session. So there also you have it's created HTTP session. Object that was initiated or already in place during the opening of handshake is established. Assuming that you have web application with the web page having two JavaScript WebSockets, client endpoints and the Java WebSocket server endpoints. So I don't know what they mentioned about that. Okay. Each time when a user download the web page and pause the WebSocket to connect, it would have an HTTP session associated with the two separate WebSocket sessions. So I didn't get what does it mean? Two session. So is it two same client or two client? හරියට කියලා නැහැ ටික නම්. හරි ඒ ටික නම් මට ඔළුවට වැදින්නේ නැහැ. මොකද්ද මේ කියන්නේ කියලා. Share web application status. මෙතන එක web application එක දෙන්නෙක් එක්ක කතා කරන කතාව මේ කියන්නේ. That is not true because it is not clear. Okay. HTTP session object holds a direct dictionary that developers may use to hold application data. Because there is an HTTP session instance per user of the application data is associated with the user. All Java servlet and Java servlet based technologies have access to the HTTP session object so that they are able to share the application state. Java WebSocket endpoints can get access to the HTTP session object associated with the WebSocket session in order to share application data, blah, blah, blah. But what we did is we managed to create the basic WebSocket and communicate with the server. Right? But just do a Google search and try to find out what is mean by share web application status. Just have a look at what is this. But other than this slide, I explain you entire thing. Okay, entire thing, and also you can just refer to some other tutorials because you have about 4-5 days, right? You can just have a better understanding. Okay, right? So that's it, right? It's a very tough task for me also because they just published all those things last week or 2 weeks back only, right? So that's it. Unfortunately we don't have any past papers, right? But if you have any questions, just post it to the WhatsApp group. Okay, we will have a look at it. Okay, we'll stop at this point. So in the Wednesday class we will be discussing, I don't think I have to do any revision on agile development. So they have published the last 2 topics. I hope you can read it and understand because I explained you the agile concepts in detail, and the past papers they just ask the theory. But therefore on the Wednesday class, we are going to discuss a little bit of past papers on project management. Okay, project management also last 2 topics I didn't do because they are very easy theory, right? Procurement management, managing customers, etc. ඒවා ටිකක් කියවගත්තම තේරෙනවා. හරි. හැබැයි ඔයාලට exam එකේ වැදගත්ම costing සහ cost management සහ time management දෙක. හරි. මොකද ඒ දෙකෙන් තමයි ඔයාලට එන්නේ Gantt chart නේ මොනවාද? PERT chart සහ ඊළඟට costing questions එනවා ගොඩක්. Right. අපි ඒකේ past papers question එකක් දෙකක් කරමු Wednesday. Okay, right. We'll stop at this point.